We throw the word paradox around all the time. We use it for brain teasers, for weird facts, for anything that just doesn't quite seem to add up. But what if I told you there are actually 5 totally distinct kinds of paradox, and that learning to spot them can give you a seriously powerful tool for clearer thinking? So let's just jump right in and break our brains a little bit. Take a look at this sentence. This sentence is false. Now, is that statement true? Well, if it's true, then it has to be false, right? But wait, if it's false, then that would make it true. That feeling of your brain tying itself into a little knot, that's exactly what we're here to unravel. And that feeling is what we usually just call a paradox. The common definition is something that contradicts itself, or at least it seems to. But honestly, that's a pretty messy definition. It kind of just lumps a whole bunch of really different kinds of problems under one big, confusing umbrella. So today, we're going to bring a little order to all that chaos. Here's the game plan. We're going to break down these so-called paradoxes into 5 distinct categories. We'll look at the real logical contradictions, we'll dive into impossible questions, we'll look at facts that just feel totally wrong, and we'll even expose a couple of types that are basically just clever tricks. By the end of this, you're going to have a super clear framework to make sense of it all. First up, we've got type 1, the true logical contradiction. These are the real deal. These are the situations where logic itself just seems to fold in on itself, where every single possible answer you can come up with is provably wrong. Remember that sentence we started with, the liar paradox? That is the classic grade A example. You literally cannot assign a truth value to it. Any answer you try to give it, true or false, immediately proves itself incorrect. There's no logical escape hatch here. It's a perfect, self-contained, brain-melting contradiction. And these true paradoxes, they usually have a few key ingredients. A lot of them are self-referential, a sentence that talks about itself, which creates this inescapable loop. Or they might be built on definitions that are mutually exclusive, like the old classic, what happens when an unstoppable force meets an immovable object? Well, by their very definitions, if one exists, the other just can't. The very setup of the problem guarantees a logical crash. Okay, next up, let's talk about type 2, impossible questions. Now, these are a totally different beast. They aren't impossible because of some logical failure. No, they're impossible because the question itself is built on fuzzy, ambiguous terms. There's just no single, universally correct answer. The perfect example of this is the ship of Theseus. Just imagine a famous historic ship in a museum. Over decades, as the old wooden planks start to rot, you replace them, one by one. And you keep doing this until, eventually, not a single original piece of wood is left. So the question is it still the ship of Theseus? And here's the twist. Saying yes and saying no are both perfectly logical answers. You could argue that identity is all about continuous history and purpose. Or you could argue that identity is tied to the original physical stuff. Neither one of those arguments is logically wrong. See, the problem isn't the logic. It's that we, as humans, don't have one single agreed-upon definition of sameness. Now we get to type 3, and this one's my personal favorite. Counterintuitive facts. These are things that sound completely absurd, totally contradictory, but they're actually provably true. These aren't paradoxes you solve. They're truths you just have to accept, even if your brain is screaming at you that it can't be right. All right, let me ask you a question. Say you're in a room full of people. How many folks do you need in that room to have a better than 50-50 chance that at least 2 of them share a birthday? Your first instinct is probably a pretty big number, right? Maybe 183 people, half the days in a year. Go on, take a guess. The answer is 23. That's it. Just 23 people. With only 23 people in a room, the probability of a shared birthday is already over 50%. I know it feels completely wrong, but the math is just undeniable. And this really highlights the key difference here. This isn't a logical contradiction like the liar paradox. This is what's called a veridical paradox, which is just a fancy way of saying it's verifiably true. The only contradiction is between the cold, hard math and our gut feeling. Once you actually understand the probability behind it, the paradox just melts away, leaving behind a super fascinating, counterintuitive fact about the world. And now for our final categories, which we're just going to group together, the flawed paradoxes. You can think of these as the imposters. They look like paradoxes, they smell like paradoxes, but really they're just clever math pranks, optical illusions, or simple misunderstandings in disguise. So take the famous infinite chocolate paradox. You've probably seen this one online. You make a few clever cuts on a chocolate bar. You slide the pieces around and voila! You've got the same size chocolate bar as before, plus one extra square. Free chocolate forever. Sounds way too good to be true, doesn't it? Well, that's because it is. This is what's known as a Fawcettical paradox. It looks true, but it's actually false. The trick is all in what you don't see. When you rearrange the pieces, you create this tiny, almost invisible sliver of a gap along the diagonal cut. And the volume of that missing chocolate, it's exactly the same size as that extra piece you created. It's not magic, it's just a really, really brilliant geometric trick. Here's another fun one. There's this famous mathematical proof that claims it can demonstrate through a process called induction that all horses are the same color. It seems totally logical and builds this case that feels, well, unbreakable. But, just like any good math prank, there's a tiny hidden flaw. The proof relies on showing that if you have a group of horses of the same color, adding one more horse to the group doesn't change anything. And that logic works fine for groups of 3 or more, but it subtly, cleverly breaks down when you're looking at a group of exactly 2. There's no overlap to guarantee those 2 horses are the same color as each other. And because it fails for that one specific case, the entire proof just falls apart. It's a paradox built on a clever but totally fatal mistake. So why on earth does any of this matter? Why go through all the trouble of sorting paradoxes into these neat little boxes? Well, because it gives us an incredibly powerful framework for clearer thinking. It takes a big, confusing mess and turns it into a set of distinct problems, each with its own rules. Think of these 5 categories as more than just labels. They're tools for your mental toolkit. So now, when you're faced with a tricky problem, you can ask yourself, is this a true logical knot like the liar paradox where I shouldn't even bother looking for a simple solution? Or is it an unanswerable question like the ship of Theseus where I really just need to define my terms first? Could it just be a surprising fact that's messing with my intuition, like the birthday problem? Or is there a hidden trick, a flawed assumption I'm missing, like with the infinite chocolate? Because at the end of the day, the goal isn't always to solve the paradox. The real goal is to correctly identify what kind of problem you're actually facing. Is it a dead end? Is it ambiguous? Is it a trick? Or is it just a weird fact? Answering that question, that's the real solution. That's what turns confusion into clarity. So I'll leave you with this to chew on. That seemingly impossible problem you're wrestling with at work, or that argument you keep having that just goes in circles, which paradox in your own life is actually just a problem that you haven't put in the right box yet?